Let's talk about factoring completely today. So we need to start recognizing when polynomials have GCFs prior to factoring. So factoring is the factor by grouping stuff we've been doing. We're going to use the ABC and this X to help us organize. But what we need to start doing is noticing right away when there's something there that we could pull out from the start. Like 2, 28, and 96 are all even. So I can make this a simpler polynomial by pulling out that GCF of 2. So when I do that, I'm going to have half of everything. So x squared, only 14 x's now, and I'm going to have what's left there, 48. Now there's a good reason for this. One, it's taking it down to basically the primes. Like you can't take it down any further. We want everything that goes into this polynomial. Another reason we do this is so that we all end up getting the same factors, because if we forget to get out this 2, there are actually like 3 different factors we could get out instead. So we want to make sure we all have the same answer. And then the third option is actually more just selfish of us. This polynomial right here is a lot easier to factor than 2 times 96 would be. So let's go ahead and factor it. So remember, A, B, and C, don't go to your original now. You don't want to look at that. Look at your new polynomial right here, the simpler form. In fact, let's go ahead and move our 2 over here to what my factors are, because that's part of my answer. I'm also going to get out those 2 binomials I normally do. Now you don't want to lose it because GCF, that F stands for factor. So it is one of my factors. So don't lose it. Just put it to the side for now. You don't have to write it again. Alright, so now my A, B, and C, 1, 14, and 48. 1, 14, and 48. Now how quick are you at this? A times C is 48, and B is 14. What multiplies to the top one, 48, that adds to 14. I hope you were thinking, what are you thinking, 6 and 8? The 6 and 8 are the ones to go with right there. So it doesn't really matter the order there. I'm going to go ahead and just put them in just like I wrote them. X squared, and I'm going to split this 14x into 6x and 8x, and then bring down this 48. So at this point we are factor by grouping. So let's go ahead and take those first 2 things. What do they have in common? They both have an x and nothing else. So when I pull out that x, I have 1 left of my 2 here, and just the 6 left of my 6x. Pull down your plus from the middle, down here. 8 and 48, both divisible by 8. So then I've got x and 6 left over. It's perfect because I wanted that matching factor right there. Go ahead and write it as one of your factors. And then that leftover stuff on the outside is the other one of your factors. So in case you've missed it, what we're really doing is pulling out a GCF of x plus 6. It's a very smart thing. That's why we love factor by grouping. All right, let's try our next one. 6n squared plus 12n plus 6. That's a lot of 6's there. I bet 6 is a GCF. And it is. So let's go ahead and pull that out. We've got just 2 n's left, and over here, don't forget that there is a 1 there. You can't just say there's nothing there. 6 divided by 6 is 1. We didn't say the 1 here because we had the n squared to talk about. We don't have anything else here to talk about. So my first factor is 6. We put it over there in my answer, so we can forget about it for now. Now, A, B, and C, this is the first time I want you to write your x for yourself. So A times C, 1 times 1 is 1. And then it needs to add to our B, 2. So which 2 numbers multiply to 1 to make 2? Well, that's 1 and 1. 1 times 1 is 1, but 1 plus 1 is 2. So I've got my n squared plus 1n plus 1n plus 1. Let's do some factor by grouping. N squared and 1n have an n in common with an n plus 1 left over. So notice the n's out there, so 1 left over. My n's out there, so just the actual number 1 right there left over. Pull down your plus. Nothing really in common here except for 1, which gives us a lovely n plus 1 left over. Because we like it, because that's exactly what we should have had there. So we've got n plus 1 and another n plus 1 on the outside. Take a look at that, n plus 1. So the way we wrote it is just fine, but there's a shorter way of writing this that I want you to get used to, because you'll probably see it like this at some point, and you'll probably want to start doing this yourself at some point too. Instead of writing it twice, just say squared because you have 2 of them. Alright, let's try out our GCF of the next one. So 4, 14, and 10x. First thing I notice is they all have x's. Usually we start with the greatest exponent of 2 and then have none at the end. So let's go ahead and pull out that extra x. Also 4, 14, and 10, they're all even. So they're all divisible by 2. The only other thing we could have maybe pulled out of there is a 4, but a 4 doesn't go into a 14 or a 10. All right, so GCF of 2x, what's left over when we pull that out? 2x squared, so we have one less x now, just a 7x left in the middle, and a 5 left at the end. Take a quick look at that. So 4 divided by 2 is 2, 14 divided by 2 is 7, 10 divided by 2 is 5. Took one x away, took an x away, took an x away, because it's out here now. So my first factor is 2x. Now we've got to find those two binomial factors as well. That's where factor by grouping comes in handy. We need to split up that 7x. Remember how it goes. First times the last. A times c, that's 10. Needs to add to the middle one, 7. That's the one that's being split. Hopefully you've already thought of it as 2 and 5. If you didn't, sorry, didn't mean to spoil that for you. So let's go over here and split up our 7x. Makes sense to put the 2 with the 2. It makes sense to put the 5 with the 5. So I still have 7x there, it's just in two places. Let's go ahead and do some factor by grouping. Obviously a 2x, because they both have, say, 2x. So you've got just one x left over there. And if I have everything over here, just remember 2 divided by 2 is 1 left over. Pull down that positive, and you know that 5 and 5 must have a 5 in common. So I've got an x and a, don't forget about it, 5 divided by 5 is 1. So my first factor there is the thing repeating, x plus 1. And my second one is the 2x plus the 5, the stuff on the outside. Alright, last problem. Can you think what goes into 15, 80, and 60? We don't need to check the variables this time because it's 2, 1, none. Did you get it? It's 5. We've got now 3x squared left over, 16x, and negative 10. That's going to be easier, much, much easier than 15 times 60 was. So that's our selfish reason for pulling out the GCF, though there are some real reasons we do it too. Alright, now let's go ahead and do our little x. First times the last is negative 30, and then that middle is positive 16. So if it is multiplying to a negative, one of those must be negative, because 2 positives makes a positive, 2 negatives makes a positive, so it must be negative positive. And because it's adding to a positive, our smaller one must be the thing that's negative so that it can cancel out all the way to 16. So let's go to the side and do some side work. What are our factors of 30? 1 and 30, we said again, the smallest one should be negative. 2 and 15, 3 and 10. What else do we have? 4 doesn't go in. What about 5? We got 5 and 6. Anything so far? Let's try them out. We've got positive 29. We've got 13. We've got 7. And if we add these two together, we get out 1. And now we're at 6. So guess what? This right here is not factorable. Unless I made a mistake up here. I did make a mistake. 60 divided by 5 is not 10. That is 12. That's always a check to make. So that's what happens if you accidentally do it wrong. Sorry about that. Let's go back here. It's been a long day. 60 divided by 5 is negative 12. So what we should have been trying is negative 36 by adding to 16. So let's try that again. Same rules apply though. 1 and 36, smaller one should be negative. Negative 2 and 18. Oh, and look, we don't even have to go any further. That was a lot easier than that first one made it out to be. Had it really been that first one, that would have been a not factorable one. You would have just rewritten it just like this. This would have been your answer. But this one was factorable. Let's keep going. That's why it's always nice to do a double check. It makes sense to put the 18 near the 3. Because they're both divisible by 3, and the 2 next to the 12 because they're both divisible by 2. So that's what I'm going to do. Splitting my 16x into 18x and negative 2x minus the 12. So these have a 3x in common with an x plus 6 left over. These, don't forget to pull out that negative right there. They have a 2 in common, which gives us an x plus a 6, because negative 12 divided by negative 2 is positive 6. So our first factor is that thing that's repeating, x plus 6. Second factor is right there, lovely 3x minus 2, the stuff on the outside. Alright, you're all done. If you ever want to check it, all you have to do is distribute the 5 back into that first one. So 5x plus 30. And then FOIL it with that second one. So you 5x times the 3x, that's 15x squared. You've got 5x times that negative 2, that's negative 10x. 30 times 3x, that is 90x. Gotta be careful with my math since I've already messed up once. And then positive 30 times negative 2 is negative 60. Double check that right there, that's 80x. And you've got exactly what we started with. So good double check. Alright,